All right, guys. Last section of new stuff for the rest of the year, right here. This is the last time I'm going to teach you something new. I know, it is sad. I only have, what, 4 more days? 5 more days with you guys. That's it. 5 days. That's it.
Next 12 more days. I want to go.
I'm not counting today. I'm already with you. So 5 more days. All right, so guys, we're going to do section 7.4. We are having our quiz 7.1 to 7.4 tomorrow. Okay? Don't make that face. All right, so today we're going to look at the properties of logs and actually using them, which if you know your properties of exponents, you should be a lot better off today because they use very similar properties. And then the change of base formula, you will have to memorize that. It is not hard to memorize. And it allows you to use your calculator for any log, no matter what it is. What's the common base for logs? 10. So right now the calculator only does base 10. But there's a trick that you can actually get it to do anything you want it to do. Okay? No. All right. Yeah, right. Oh, your calculator, if you hit the log button, it's by default base 10. But I'm going to show you a formula today that you can do for no matter what the base is. You can still get it to do it. All right, guys, so the properties of logs are very similar to your properties of exponents. So, like on this one, x squared times x to the 5th would give you x to the 7th. You add your exponents. Kind of that same idea. It's a multiplication problem, but we add. That same idea works for logs. We're going to practice today stretching logs out and condensing them back together. Depending, if we had time to finish this chapter, it would be very, very important that you knew how to do that in order to solve and simplify things. But on here, so right now this is log base b m times n, so we can split that. Just like here, it's a multiplication problem. Normally you would add your exponents. It's multiplication. I can split it, so now I'm adding the logs. So I put the log with the m, and I'm putting the log with the n, and I can just add them in between. So it's that same idea of your properties. So the second one, x to the 5th over x squared is x cubed because you subtracted. Same idea, if it's log of a division problem, a fraction, you will subtract them. Okay? So log of m minus log of n, so the top minus the bottom. And then down here, x to the 5th squared would give you x to the 10th because you multiply them. So same idea here, it's a little bit different. We kind of think of this as we distribute this. So I'm going to actually take this exponent and you're going to multiply it way out in front. It jumps out into the front and then log of m. Okay? I know, right? So let's just kind of jump in using these properties. See what we can figure out. All right, so what is the expression written as a single logarithm? So the first thing you need to realize is your bases have to be the same in order to put them together. Otherwise, they're not the same thing. So we would get log base 4 of what? No. A subtraction comes from division. Yeah, it's the flip-flop of that property. Oh. So it would be the log base 4, that's all the same. Since it's subtraction, it flips this into division. So it'd be 32 divided by 2, which is 16. But, hold on, let me take this one more step forward further. It's log base 4 of 16. What is that? It is 2. Because 4 to what power equals 16? 2. So you went from log base 4 of 32 minus log base 4 of 2 is 2. So the properties allow me to kind of put things back together where I actually then could go further and actually get the answer to it. Fun, right? All right. Let's look at the next one. So the number out in front, that actually comes back as an exponent. So that's going to make this. And then what does the addition do? Multiplying. So I'm going to have log base 2. This becomes x squared. So that's totally what I meant, x to the 6. Don't ask me why I wrote it. I was looking at that too, maybe? I don't know. Yeah, that's going to come back up here. And then the 5 will come back here. And y to the 5th. How'd we do? It's using the properties backwards. We're going to use them forwards and backwards. So a number out in front comes back as an exponent, right? So that's going to flip back up here as an exponent. And since it's adding, when we condense it down to 1, you actually multiply them back together. That's one of the properties of logs. That's how they work. If I'm going backwards compared to the property page you're looking at, the property page shows it as 1 log splitting it. I'm starting with split logs, and I'm taking them back, like the other way. Right, because this problem started with an addition sign. So the addition one, when I put it back to 1 log, you multiply them. Yeah, you got to look at which way I'm going with my logs. So the next one, there's no number out in front, so there's no exponents I need to put on there. But what's a plus do? You multiply. So log base 4 of 15x squared. Check. You got one. It just takes practice. This is something we're not used to seeing. So we're just going to do a whole lot of drill and practice here. All right. So what do we do with the 2? Comes as an exponent. So this is going to come up here. So it's going to be 6 squared, which is 36. So log base 4 of 36, subtraction? Divided by 9, which is 4. Log base 4 of 4, which is what? It is 1. 4 to what power equals 4? 4 to the 1st. Yeah, I know. All right, so use the properties of logs to rewrite and simplify. So, yeah, I can go back. But guys, we're just doing a lot of practice with these properties. That's what we're practicing with, okay? So if you're frustrated, just hang with me. We're going to do lots of practice, okay? I know. Logs are something very new and different for you guys, so it's...
I mean, I understood it. Today, it's like, yeah, we literally just like moved stuff. It was there, done.
Jacob, you okay? All right. So using the properties of logs to rewrite and simplify. So let's go ahead and try to pull this out a little bit and see what we can do with this. Let's use our properties. So a multiplication problem is going to split apart as addition. And where do exponents go? Out in front. So if I'm doing this, it's kind of like 2 separate problems, right? I'm going to do this one first. So I'm going to have 2, because that's my exponent. It comes out in front. Log base 3 of 9 plus log base 3 of 2. Hold on, I can actually simplify a little more though. But let's make sure we're okay there first. All we're doing is using those properties where it takes your exponents and pulls them out in front, and then the multiply is going to split this into 2 logs with a plus sign instead. And again, the reason we do this is just to try to simplify some stuff. Right now, I can look at this. What's log base 3 of 9? 2. 3 to what power equals 9?
Oh, yeah.
Yeah. So this right here 2. So I really have 4 plus 4 log base 3 of 2.
Oh, that's not complicated at all.
Gotta end the year with a high note, right? Anthony better watch the videos for sure. Yep. No, they're just finishing chapter 8. Rational expressions. The blue things across around the room. All right. So log base 7 of 1 over 147. Good. Log base 7 of 1. Division makes you subtract log base 7 of 147. Yes. Yeah, if you did the 147 before the 1, it's wrong. It has to go top down.
Log base 7
The first one wouldn't have made a difference because it's adding. Yes. Yeah. Hold on. Let's make sure we're okay here. Question? Yes, but I don't know why you would ever want to do that. But yes, you could. Yes, you could. All right, so, guys, take a look here. 7 to what power equals 1? 0. So this is, in essence, nothing. It's fun. Can you do 7 to some power equals 147? No, you can't. So I can't really simplify this one. So my final answer then is negative log base 7 of 147. Okay, next one. Go ahead. I love this stuff. This I like. You like this stuff? Oh. I almost liked you there for a minute. All right. So log of 6 over 200.
log 6 minus log base 2.
Nobody had any inkling to do something to that first?
Well, yeah, it's still 10. Log base of 10.
Okay, yeah, that's log base 10, but nothing else.
Oh, goodbye.
Yeah, I would probably simplify that. 6 over 200.
3 over 100.
3 over 100. So log, you're right, that's base 10. It doesn't specify. So as we talked about yesterday, it's your common log. So 3 over 100.
So it would just be log
Minus, we'll go one step at a time, because equals log base 10 of 100. Any questions to that step? Jared, you okay?
Can we just say log base 10? Can we just say log?
You can just say log. If you don't have to write the base 10. I'm only doing it because it helps people on this next step. Because then if you look right here, we can simplify this. That's 2. So log base 10 of 3 minus 2. Right, because 10 to what power equals 100? 10 squared. This is straight up algebra 2, guys. How you feeling?
Tired.
Yeah. Yes. Do I put it in parentheses? You could. All right, guys, let's talk about something real quick, because Jesse brought up a good point. On this last problem, do you have to put this in parentheses to keep this as something separate so I don't actually do 3 minus 2 as 1? It's a good question. Do you have to?
No.
You do not have to. Kind of like with exponents, like whatever the exponent is right next to is what it goes with. Same idea with logs. the fact that this 3 is right next to the log base 10, that goes together. This does not. It's separate. If you want to put it in parentheses to make yourself feel better, you can. That's fine.
So the first, I just solved like
If you did and actually got a number there, you would never be able to simplify it down to this. Huh? Yeah. All right, so expand each log expression. Hold on. Let's do the first one here together, and then I'll let you guys try this one on your own, see if we can do it, okay? So let's do the first one. Notice how many different things are being multiplied together? 3. So how many things should be added together? 3. We're going to split all of these apart. So you're going to have, now does this 3 for an exponent, what does that go to?
Yes.
But what part of this is it? It's only on the x. So as I'm splitting this, you're going to have log base 4 of 5 plus, then I'm going to move this 3 of an exponent in front, 3 log base 4 of x plus log base 4 of y. And that would be it expanded all the way up. From there, nothing. I just asked you to expand. We're not solving. We don't have an equal sign. We won't get to those sections in this chapter, unfortunately. So you guys go ahead and try the other one up here. If you haven't done it at this point, you ain't gonna do it. All right. So what did we have? Do I have to write base 10?
No.
No, it's implied. So log of 3
2 log x.
plus log of y?
Log.
Loggy. How are we feeling? You okay with that one? Sorry. All right, so expanding this one, there was a radical. How should we probably rewrite that? Yes. So what he said with his parenthesis on, parenthesis off stuff. So really I have 3x to the 1/2 over 7. Because if we have exponents, we can take exponents and put them in the front when we're expanding. All right, so we have, before we even start expanding this, we have a multiplication on the top, and we have a division going on. So we got a lot of properties all working together. So on the top, what's the first thing I'm going to write? 1/2 log of 3. I got to split this whole thing apart. So I'm just doing the 3 first. So 1/2 log of 3. It is plus 1/2 log of x. Because this half goes to both the 3 and the x. It goes to both of them. Then what? Minus log of 7. Yeah, since it's a division, that's why it switches to subtraction. That wasn't terrible. Yeah, it was. All right, next one. What's the first thing you want to do? Now, back to Jesse's parenthesis question. Do you see how all of this is in a parenthesis, showing you that all of this is kind of grouped with that? No, I'm not making fun of you. You'd asked parenthesis question. There's where it showed up again. So really, this is log base 5 of, well, not splitting it yet. How would you rewrite this? X to the 1/2. Okay, you could do it all in one step once you're comfortable with it. All right, so that will give you log base 5 of 2. And what? Good. 1/2 log base 5 of x.
Can you explain that?
My 2 looks a little funny. Is that what's throwing you? This whole thing? I went ahead, since it's radical x, I switched that to x to the 1/2. So then I just did log base 5 of 2. These are being multiplied, so I would switch to an addition sign. And then you take your exponents, and they go throughout out in front. Sorry. So 1/2 went out in front, and then the log of x. Yeah, the multiplication splits to adding, exponents come out in front. Bree, okay? All right, guys. So condense the log expression. So if it wants you to condense it, how many logs should you have?
1, 2, 3, 4.
You should have 1 at the end. I'm condensing it all the way back down. So let's take a look. I know I have log. So I know I'm going to have just 1 log when I'm done. Let's try to pull all this back together. Because I'm condensing it, I want you to push it all the way back down. Sure it is. So what happens to this 1/2? Goes to an exponent on the x. Good. So it becomes log radical x. Because that's 1/2. It becomes, this comes over here to the 1/2 power. Are you allowed to leave fractions for exponents?
9.
A couple of you lost some points on your test because of that.
Wait, what did I get on that test, by the way?
I can show them to you at the end of class today. They're graded. I just haven't put them in a grade book yet. All right. What's the plus mean? You're going to multiply. Where does this go? That's an exponent. Nope. And I'm done. And that's it. It is awkward just... Do you want the 10? That make you feel better? If you want to write the 10, you can write it every time. It's okay.
So would 1 log be impossible if it was greater? It's not 1.
Huh?
If log of 1 to 1.
Log base 1?
Yeah, if log base 1 of 1 would not equals 1.
Would equal 0. Log base 1 of 1 equals 0.
Log base 1 of 1
You're with me, right? All right. All right, guys, here we go. Condense each log expression. You guys want to try this on your own?
Yeah.
Give it a try. Let's see what you can do. All right, guys, so on the first one's definitely better than the second one. The second one kind of threw you guys a little bit. All right, so this this 2 here comes in as an exponent. And then what does the subtraction do? Divide. So I'm going to have a single log. I'm going to have x plus 2 squared. The subtraction tells me divide by x. I can't simplify that. Best case scenario, that would give you x squared plus 4x plus 4 on top, which doesn't simplify the x in the bottom, because we just did chapter 8 not long ago, and you learned that in chapter 8. This is as far as that one goes. Right there. All right. For this one, personally, the first thing I would do is distribute this. You can distribute it to this log and to this one. So we'll go one step at a time here. So I'll have 1/3 log base 2 of x plus 1/3 log base 2 of x plus 1. All right, I just distributed the 1/3 to get rid of those brackets, which were driving some of you crazy. Okay, I just moved the page. It's still there. All right, and then what do we do with the number out in front? Where does it go? It's an exponent. And what does it mean to have to the 1/3 power? It means it's a cubed root. So I'm going to have a common log for both of them, right? Just a single log, log base 2. That becomes the cubed root of x. What does a plus sign do? You're multiplying by the cubed root of x plus 1. Yeah, I can. The other way you could have done that if you did not distribute first if you worked on the inside first, you would have had log base 2. This would have made you multiply those, x and x plus 1. And then all of this goes to the 1/3, which would have made this go as an exponent for all of this, which would have stuck it all back underneath here. I have my heat turned all the way up. Yeah, it was freezing in here. I tried to take a nap earlier, and it was so cold I couldn't sleep. During my planning period. I didn't feel very good this morning. If I had a blanket, I thought it would have been. All right, so change of base formula. Here we go. This is really easy. Don't panic on me, okay? Don't make that face. It's not hard. All right, so we can use the calculator to find values of logarithms with base 10. That's what your calculator is set to do. But evaluating other logs is not as simple as just hitting the button and typing it in. I have to hit a couple buttons, okay? So, like if I asked you to find log base 9 of 243. So 9 to what power equals 243? It's not perfect and pretty, right? But what if I want to know? Right? So we need to use the change of base formula. So there's a lot of mumbo jumbo up there. Let me explain it to you in layman's terms, okay? Yeah, that's how I usually would teach. Let me teach like English to you here. So if I have this log, right? Notice the x, notice the a. A is my base. I'm going to take the log, this base here, think of that as base 10. I could use my calculator. So I'm going to do log of x divided by log of whatever that base is. So for example, on this one, I could do log of 243 divided by the log of my base, which is 9. I can use my calculator. So grab your calculator.
Wait, what?
If we use this formula, you can use it as a base 10. It allows you to switch it so you can use your calculator. Well, what? No more calculator works. It's a decimal because it's not 9 to whatever power is not pretty for 243. So let's make sure we're all okay with the calculator. So let's hit log of 243 divided by log of 9. And it is 2.5. Try it. Type in 9. Try it. No, it's not. 2.5. Guys, when you use your calculator and you type in, hit the button that says log, it opens a parenthesis. Okay? Type in 243, close it. Then divided by log of 9. Gotta close it. Otherwise, it's doing the log of something and another log included, and it's a big ol' mess. But again, try it. Type in 9 to the 2.5 power. It's 243. Seth? Of 9. Guys. Time out. Take it back a step, guys. You didn't get 2.5? Yeah, you should get 2.5. Then I said, check this, because this is asking you 9 to what power equals 243. So we checked it. If you type in 9 to the 2.5 power, you do get 243. It works. I'm just proving to you that the change of base formula works. Yeah. Without the parentheses. How did you put in log base 9? It automatically puts a base of 9 in? Huh? Nope. And too bad when you take the ACT, can't use it then either. They'll let you use graphing calculators, but not your phone. Guys, it's not that hard of a formula. Suck it up and do it. All right, so here we go. There's 3 problems. Take a minute. Figure them all out. Round to 4 decimal places. All right, how about the next one? And the last one? All right, how we feeling? At first, you guys were like freaking out on me. Are we doing a little better? Paige? Probably take a half point off. I mean, this is straight up like rounding rules. I'd probably take half point off. If you're rounding to the fourth spot, so look at that fourth number. The number after the fifth number, if it's 5 or higher, it rounds up. If it's 4 or under, it stays where it is. It's your rounding rules. Does that make sense, though, how I tell if it rounds? Okay. No? Yes? That's cute. I've never heard that. All right. Your assignment is an overkill quiz review. I told you guys this yesterday. It really is